And so this is part 15 of the circulatory system, blood. And now we're going to get into platelets and clotting. This is the first one of those talks. There's going to be probably a couple. So platelets control bleeding, which is nice because it's actually happening all the time and you might not realize it. It's more than when you just get a paper cut or, in some cases worse. There are lots of times the inside of your body is constantly controlling bleeding, right? And so let's talk a little bit about that. All right. So the idea of us keeping all the blood where it's supposed to be is called hemostasis, right? Hemo meaning blood and stasis meaning in its place, essentially, in a nutshell. So hemostasis involves primarily the cessation of bleeding, meaning clots and stopping leaks and all that good stuff. When we have the inability to stop bleeding, and now we're bleeding too much, we call that a hemorrhage, right? Hemorrhage. So there's three main hemostatic mechanisms that we're going to use. First, we're going to look at how the blood vessels are going to spasm. They go from being whoop, like this to, and like you get a little cut right here, right? So they do this thing where they'll actually kind of spasm in that area, and it kind of shunts the blood flow just a bit. The next thing is the platelet plug, which we all know and love. It kind of starts forming, and it's big, and it's a little messy, and it's got a lot of fibrin and a lot of parts and a lot of prickly platelets that have been activated. And then finally, the process of like actually making a blood clot, right? And that blood clot will stop the bleeding, and it'll compress itself down, and it'll become a good old-fashioned scab, right? The scab formation. And so platelets are kind of interesting because they're also biological signaling elements in platelets when they become activated that actually like cause all of this to happen. So it's kind of cool. Platelets, what are they? What are you, platelets? You're tiny little fragments of a megakaryocyte cell. So like in the bone marrow, there are these cells, right? So say this is like a blood vessel in the, bone marrow. And so megakaryocytes, like they sit like up here on the blood vessels, right? So here's a couple megakaryocytes. Just happy. And so then they stick their feet down into the blood vessel like this. And I think I have a cool graphic coming up, but hey, you're going to miss out on this drawing if I don't do it, right? And they like break off little pieces of their feet. So like a platelet is actually not a cell itself. It's a fragment of a cell. And those megakaryocytes are the cells that they are fragments of. And so they're teeny tiny. And so what happens? Sorry, had to break out there. So right, so they're little fragments of the megakaryocyte cells. They're super tiny, and they contain granules, which are important for things like clotting. So clotting factors, other types of proteins that are going to use in the entanglement process. They actually have this very complicated internal structure. And one of the things we know about this is there are canals, right? Specifically inside of them. So there's like this directionality and this order and this specificity, and that's probably totally wrong because I was not a platelet researcher in my day. We also know they move like amoebas. Like if you remember amoebas from back in biology, they kind of move like by slugging around. And it's kind of interesting stuff. So the normal platelet count is really high because we've been talking about this volume of the microliter. So whereas most white blood cells sit in the 5,000 to hopefully not up to 10,000 range, platelet counts are crazy high, like 130,000 to 400,000 platelets per microliter. So lots. Platelet form and function. So platelets do stuff. They secrete part from those granulars vasoconstrictors that help in that important first process of like the vessel flexing and becoming smaller and closer together when there's a tear or a lesion causing blood flow to slow in that area, right? They're also going to like get really brambly and they start sticking together like a bunch of like goat heads, you know? And that's kind of the first thing they do. And that forms eventually what we call a platelet plug. And that'll seal the small break temporarily. And then it kind of moves on to the next stages. They also secrete procoagulants or things that make you actually clot. clotting factors is another term for these awesome biological chemicals. And so what this does is they are able to clot by grabbing onto each other and then grabbing onto and initiating these fibers that, act as duct tape in the wound, and then they get everything stuck together, and then they compress it down, right, and make it really flat. And that's the scab that we all know and love. Scabs. After the tissue heals underneath, they also initiate the formation of a clot dissolving enzyme. So that's kind of helpful. And also, part of those granules are full of chemicals that will attract other types of white blood cells, or really, the true white blood cells like neutrophils, monocytes, and they will help phagocytose, destroy bacteria. Also, they're going to secrete growth factors that tell this tissue that has been damaged, to start the repair process. And so that's kind of good stuff, right? A lot of stuff going. Oh, look, here's a megakaryocyte. Remember when I drew them? They had a green smiley face and lots more feet. Right, yep. And then here's the platelets that are being broken off. Okay, so they are large. And this is in the red marrow. Right, and so one of the things we call these, I should mention this too, is this is like a pseudopod, which means fake. Not really but like the other branch, I guess, really. Okay, it's pretty helpful. Okay, so platelet production, how are they born? They're born of thrombopoiesis. And you know what, let me go ahead and get into that in the next video a little bit more. This is probably a good place to just do the handoff. Okay, well, I hope you all are having a wonderful day, and let's get into this in the next video. All right, bye.